Okay, so today we're going to be talking about something called compound events. Compound events means there's more than one in a row that are going to be happening. When we were making sample spaces where we talked about the probability of maybe spinning a spinner and rolling a die, that's a type of compound event as well. So we're going to talk a little more about what they are. We're going to talk about what makes an independent and a dependent event, and then we're going to find probability of both of those types of events. Okay, so on your first page, a compound event consists of two or more events. Two or more events. Now, first type are independent events. Events are independent if the probability of the events are not affected by one another. For example, when we roll a die and flip a coin, what we get on the coin has nothing to do with what we got on the die. They don't influence each other. They're both kind of random things. So that would be a good example to write here. Rolling a die and flipping a coin. The other type of event is called a dependent event. Events are dependent if the probability of one event is affected by the other. So for example, we have a bag with marbles in it. If I draw a blue marble out and then I don't put it back and I pick another marble, my probability is going to be changed. Okay, so let's write this as drawing a blue marble. And then I'm going to write without replacement. That means I'm not putting it back. Then drawing another. We're going to have some ghost writing. Blue marble. Okay, drawing a blue marble without replacement, then drawing another blue marble. So let's look at what happens when we do that. Right now inside the bag we have 5 blue marbles. How many marbles do we have total in the bag? Can anyone count them? 10. So the probability of drawing the first blue marble is 5 out of 10. That's the probability of getting the first blue marble. Now when we draw the second blue marble, okay, one of these blue marbles is gone if we drew it the first time. So actually I shouldn't color it red, I should do it in brown so it sort of blends into the bag. Okay, now how many blue marbles are there?
4.
Andrew? 4. How many marbles are in the bag now?
9.
9. So the probability is changed to 4 out of 9. There you go. Okay, makes sense? Do you see why that probability is changed? It's almost always drawing things and not putting them back that results in a dependent probability. Okay, to find the probability of independent events, when we have a P and then something in parentheses like we did on the quiz. On the quiz, we had something that looked like this. It said P parenthesis 3. That meant the probability of getting a 3. So this means the probability of event A happening and then event B happening. And to find the probability that those two things are going to happen in a row, we just multiply the probability. So we multiply the probability of the first thing happening times the probability of the second thing happening. So our example says, what is the probability of rolling a 4, then flipping heads on a coin? So rolling a 4 is our first thing. So we have probability of getting a 4, then heads. Okay, we're going to take the probability first that we roll a 4. Tony, what's the probability that I'm going to roll a 4 on any die? 1/6. Good. So we have 1/6 times, what's the probability that I'm going to flip heads on a coin? Jace? 1/2. Okay, so multiplying these probabilities, I multiply the tops of the fractions. 1 times 1 is 1. 6 times 2 is 12. So the probability of both of those things happening in a row is 1 out of 12. Okay, another example, what's the probability of spinning two sixes on a row two sixes in a row on a spinner with 10 numbers? Okay, so we're doing the probability of 6, then another 6. Okay, so first of all, what's the probability that the first time I'm going to spin a 6? Andrew? Not 6 out of 10. How many 6s are on the spinner? You don't want to use the actual
6?
number 6.
Oh, wait.
Yeah, there's going to be 1 6 on the spinner out of how many? 10. So the first chance is 10. What's the probability that we're going to spin the next 6, Travis?
1 out of 10.
It's still 1 out of 10 because when we're rolling on it or spinning on a
And then when
spinner,
you're
we
answering-
don't use up spaces, right? It's not like once we've spun it, we can't spin it again. We could spin the exact same thing.
Well, don't.
So the probability that we're going to spin 2 6s in a row, 1 times 1 is
1
1. No, 10 times 10, not 10
Oh,
plus
yeah,
10.
10.
It's 100. So it's a 1 in 100 chance that you're going to get 2 6s in a row. Okay, questions about this?
That's a very good chance.
Okay, let's see what the next slide holds. Okay, we have a couple more examples. Now, this one talks about a bag with marbles. In a bag with 10 red marbles and 5 blue marbles, what is the probability of picking a red marble, putting it back, and then picking another red marble? Now, we are putting it back, so this is still independent because since it's back in the bag, we still have the same number, so we don't have to worry about there being 1 less red marble. Okay, so let's say probability of red, then red again. Okay, what's the probability that my first marble is going to be red? Andrew?
10 out of 15.
Good. 10 out of 15. And then what's the probability that the second marble will be red? Caleb? How many red marbles do I have in the bag? 10 out of how many total? 15. So it's the same probability again. Now, I need to, whoops, I forgot my times. I need to multiply these two numbers. Before I multiply, I'm going to reduce those fractions because if I don't, I'm going to end up with a really, really big number. So what does 10/15 reduce to? Travis?
Oh, wait. 2/3.
2/3, good. So I'm going to do 2/3 times, whoops, well, yeah, 2 parentheses right next means multiplication. 2/3 times 2/3, 2 times 2 is 4, 3 times 3 is 9. So the probability is 4/9, which is kind of almost a 50-50 chance of getting red, because half of 9 would be 4.5, that would be 50%. Have any of you ever played the game Trouble?
Oh, yeah.
I'll bring that whenever we have, at the end of our class, when our class is over, at the end of the marking period, we'll have a game day where we play games. And I'll bring Trouble so you guys can actually play it. So in Trouble, you have that thing in the middle. It's like a
Yeah,
a
it's the die, and you pop it,
Yeah, and you have
throw
to
the
pop
die.
it, and it rolls the die for you, essentially.
Okay.
So whenever you're playing the game, your pieces are in your little home area. And to get out of the little home space, you have to roll a 6 first. Now it says for this problem in the game Trouble, Haley needs to roll a 6, then either a 2 or a 4. So maybe there's other people's pieces all lined up, so she would roll a 6 and then a 1, she'd run into somebody else's piece. So actually, I think you can eat them up though if you do that. But maybe she
And
wants
send
to
them
get
home.
a 2 or a 4 because she wants to send those people home. So that's what she wants. So let's find the probability that she's going to do that. So it's the probability of rolling a 2, then a 4. Okay, what's the probability that she's going to roll a 2? Nick?
It'd be 2 and 6.
Not 2 out of 6. You don't want to use the number 2. You want to think how many 2s are on the die. No, how many 2s are on the die? 1. So it's 1 out of 6. Okay, Jenna, what's the probability that I'm going to roll, or she's going to roll a 4? 1/6. Caleb, what's the probability then that she's going to roll a 2 and then a 4? No, I have to multiply these two together. Multiply your tops and then your bottoms. 1 times 1 is?
2.
1. And 6 times 6 is? 36. So the probability of that happening in that order is 1 out of 36. Okay, any questions so far? Caleb, do you understand what we're doing so far? All right, now let's talk about probability of dependent events. I think dependent events are interesting. So if they're dependent, the probability of A, then B, we're still going to multiply the probabilities together. But the second probability, we have to think about, well, if the first thing happened, how many are left? How's that going to change my probability? So it's a little different. It's called the probability of B after A. What's the probability that the second event will happen after the first event has already occurred? So it says, what is the probability of drawing a red card from a deck of cards and then drawing another red card? Okay, so first of all, probability of red. What would be, whoops, wait a second, I need to make that say red, then red again. So we're not putting the card back after we draw it. So what's the probability, first of all, that when we draw a card, it's going to be red? Jenna?
Would it be 1 out of 2?
It would be 1 out of 2, because we have 2 colors cards, right? We have red cards and black cards. There's the same number of both, so it would be 1 out of 2. Now, the next part's a little bit tricky. What's the probability that the next card is going to be red? First of all, we have to know a little bit about how many cards are in the deck. There's 52. So if there's 52 cards in the deck, how many of those cards started out being red?
26.
26. 26 of them are red. So really, the proportion would be 26 out of 52, which reduces to 1/2. Now, if we took a red out, so it's not there anymore, how many reds are left in the deck? 25. How many cards are left in the deck?
51.
51, because we took 1 out. So everything's 1 less. Okay, now we have to multiply the 2 probabilities to find out chance of that happening right in a row. Go ahead, Caleb.
Is it 25 over 102?
Good. 25 out of 102, which is roughly 1/4, because 25 is 1/4 of 100. So it's close to 1/4, but not quite. Okay, let's try another example. There are 26 letters in a bag representing all letters of the alphabet. What is the probability that you will draw a P, then a Z? So probability of P, then Z. Let's see, Jace, what's the probability, first of all, that you're going to draw a P?
Wait, there are 20. Oh, 1 out of 26.
Good, 1 out of 26.
Yeah.
Okay, now after you draw the P, what's the probability that you're going to draw a Z? Andrew? No?
Would you take the P out?
We took the P
Oh,
out.
it didn't say that. So okay, so
1 out of 25. Good. Always assume that you're not putting it back unless it tells you that you're putting it back. All right, so we have 1 times 1 is 1. 26 times 25 is actually 650. So your chances of doing that are 1 out of 650. Not a very big chance, right? That's not very
Let's
likely.
put it this way.
Okay, questions about this slide before we go on? Okay, let's try this one. Allison is making chicken wings. And this is kind of a true story because my daughter's name is Allison. And the day that I was doing this, I was making this set of notes, I was busy doing it, so I said, would you make dinner for me? And she said, okay, yeah, I will. So she was making hot wings and barbecue wings. So I made over problem. She's 14.
Oh.
She can handle, like she can put on a full meal better than me. But anyhow, that's to digress. Allison is making chicken wings and she got the hot wings and barbecue wings mixed up. There were 16 hot wings and 17 barbecue wings. What is the probability that she will pick 2 hot wings in a row? Okay, so we want the probability of picking a hot wing and then another hot wing. Because some members of my family do not like the hot ones, so we have to put the barbecue in there. Caleb?
2 out of 33.
Not quite. How many, first we just want the probability of getting one hot wing. Start with one.
1 out of 16.
No? How many hot,
33.
no, how many hot wings are in the batch?
16.
16, so we want to do 16 out of how many wings are in
33.
total. There we go, that's where the 33
Yeah.
comes in.
I'll move that one, I'm done.
Okay, now what's the probability that the next one is going to be a hot wing? Andrew? Well, I agree with the 15
15
out of 32, good. Okay, this one works out to be, let's see, 16 times 15 is 240. 33 times 32 is 1,056. Okay, if I were to divide that through, let's express that as a decimal, that'll allow us, it's about 0.23. 0.25 would be 1/4, so again, it's about a 1 in 4 chance, just like our last problem. Okay, any questions about this? Can't remember if there's another one. Nope, that's it. All right, let me give you your homework.
This one, can I go bathroom?